competition is good. And the best way to have competition is to have an open framework, to have a set of standards that we can compete with each other, but yet still work together. And when you have that, you create a very vibrant and robust technology ecosystem.
Hello, hello.
Hi, Joel. How are you?
Fantastic, Mark. How are you doing?
I'm doing great.
This is going to be excellent. We're going to have a lot of fun today.
Yeah, thanks for inviting me.
Look at that background. That's the AMD campus right there?
It is. I chose that as my virtual background, and honestly, I'm in Austin today, which is where that campus is. We're in Santa Clara. We're in Austin, and we're multinational. But that is what the weather looks like in Austin today. It's a very nice day. You're Bay Area based, Joel?
I'm in Tampa area, but we're actually Tampa Bay. Yeah. But we're actually looking to move out to Dallas, Fort Worth. So we're going to be out there in about 2 weeks.
Oh, great. Welcome to Texas. Almost.
Yeah. Have you been there long?
Oh yeah. I've been away. I've been in the Northeast for a period of years. We just moved back from California. I still split time a bit, but for the last almost 3 years, we've been mostly back in Texas, and I'm a University of Texas grad. I love the state. I hope you love it.
Yeah, I have family from Lubbock, and so they talk about it a lot, but I haven't been out there too much. I've traveled through it, but I'm excited. So we're going to be out there for 2 weeks. We're going to explore, see what's going on. We have 2 little ones, so it's going to be an exciting adventure for the family. So how long have you been at AMD?
I've been at AMD 9 years. I've been in the industry over 35 years, but 9 years as CTO and running our engineering efforts here.
What got you involved with technology to begin with?
Well, that's a great question. I've always loved technology. I was, just always loved it. Gadget guy as a kid growing up, and I did a summer job working with actually a cancer researcher who was an electrical engineer, and was just showing me all the ways that actually being an engineer, working with the data, helping solve disease. I thought that was fascinating. And that's what I ended up majoring on in school at University of Texas. I was an electrical engineering major, and I've just been so fortunate to work in and around technology my whole career.
Oh, yeah. So did you ever do anything else with, I guess you're at AMD now, so you make processors that will then be training algorithms to then help find, cures to diseases. So it's kind of coming full circle.
It is. I wish I could be solving, those type of tough problems that, creating new medicines, vaccines for the pandemic and on. But at least we do play, I think, a very significant role in providing the kind of technology that can speed the efforts of the scientists.
Yeah, that gives like a nice sense of purpose. Does that come out like corporately? Do you guys talk about that to your employees?
We do. In fact, we're very active in actually assisting directly scientists, academic institutions. We just donated over 12 petaflops of supercomputing capability to 21 universities and research institutions to speed, the research around the pandemic, whether it be the vaccines themselves, molecular dynamics studies, even social activity that could, affect the spread of the disease. So the computing is going to, I think, be put to excellent use, and our employees know that we're very active in supporting that, and they know how important our technology is in this regard.
That's pretty interesting. So I want to make sure I understand that right. So a lot of computing, I won't remember the exact number, a lot of computing you donated, but are you guys in the business of being able to do that? Or is that something that you had to spin up and create for this specific scenario?
We're definitely in the business of supercomputers, and that's the engines underneath. So, you think about the high performance products that we do, CPU, GPUs, specialized semi-custom implementations. They span everything from game consoles to new game consoles coming out this fall from Sony and from Microsoft, PCs, to the servers, all the way, gaming devices that people use, all the way to supercomputers, like the most recent announcements from the U.S. Department of Energy, where an award was given to AMD for our CPU and GPU, and working with Hewlett Packard Enterprise to develop supercomputers. It'll be the largest in the world starting next year.
That is exciting. So then will people like today, and correct me if I'm misunderstanding this. So today, can people go like a cloud service and use your supercomputers?
They do. Clouds are just now starting to do that. Joel, it used to be just the massive national labs at the various countries that could afford to put up these supercomputers, and it was for national interest, but they typically open it up for scientists in those countries or even internationally to get at those supercomputers. But it is very interesting that you say, well, can people just rent time? And that's what the hyperscalers, the big companies, whether it be AWS and Microsoft and and Google and Oracle, IBM, and so on. And that's just U.S. Same thing internationally. They're now standing up supercomputers that people can rent time, and so it just makes it easier for scientists, but also students and others to get access to that kind of computing that used to just be at these massive national labs.
So is it like a partnership with these large companies like Amazon Web Services and all of these, or can you actually go to AMD.com and like spin up a supercomputer?
Yeah, so we're the technology provider. So whether it be those big hyperscalers or whatever, we partner with systems companies to build up those supercomputers. So it's not AMD.com where you can get that supercomputing, but it is as simple as logging into one of those cloud services and just searching for the kind of capability you need, and getting an account, and away you go.
Oh, that's exciting.
Yes, it is truly an exciting development.
So I read a little bit about you leading the redesign of the engineering process, and I was just curious, open, broad question, like how do you come into an organization of that size and change it?
Well, I've always had had a great relationship with AMD over my years. So I was 35 years in the business. I've been at IBM, I've been at Apple and Cisco before 9 years ago, taking this role as CTO and running our technology and engineering. And AMD always had such a storied history of innovation. But what we found ourselves as I joined, as Lisa Su joined, our CEO, what we found was that what we had to do is marry with that incredibly innovative spirit that was and is stronger than ever at AMD, a different kind of R&D process that would allow AMD to never miss a beat, to be out there at every cycle. So every technology has a refresh cycle. It might be annual, it might be every 18 months, where you've got to come out with that next generation. And so we did have to retool engineering to make sure that that it could that AMD would in fact be on that regular cadence and not have a slip. So it was a big challenge, but a great challenge, because what it is, my sense, and certainly what I tried to do with the team, was get goal alignment, really get everyone to where they bought into not only to the vision of what we need to be, but the key levers, that if we could implement these key levers, then it could change the way in which we ran development going forward. So we spent a lot of time up front on the goal alignment. What are the challenges? Engineering is about problem solving, and what people sometimes miss is sometimes the biggest challenge is to frame the problem correctly, so that the thought leaders can get their head around it and get those innovative juices of solving the right thing. And then you have to give the team space. You have to create an environment where they can innovate, an environment where they can collaborate, an environment where they can, really, really communicate without fear, right? You don't want to, you don't want the messenger being shot. So it was really all of those elements. It was, setting the right goals, setting the right processes, even how we organized the teams, Joel. We set up to where, that we wouldn't just be working on the very next processor, for instance, that we shipped. We'd be working on one generation and the next, and then could leapfrog. When one team finishes, you leapfrog, and that way you ensure a continuity of that innovation development machine.
No, it sounds brilliant. So I was talking with Paul over at Fox, and I guess your answer might have just answered this question. I like to push out, to my email list different people and say, hey, we're having Mark on, like, give me good questions, because I'm not perfect. I don't have the best questions always. And so he says he feels like that processors are a space that if you stand still, you go backwards very quickly. How do you stay ahead?
Yeah, no question. You look at what's going on in processors, the capability is doubling about every 2 years, about every, I'll call it 2.25 years. So you can't stand still. You have to have an innovation pipeline. And it's a great question, because it used to be that the bulk of where you drove that processor development came from the semiconductor technology. You'd look at that new semiconductor technology, and that alone would allow you to shrink the chip, so you could add more transistors. You could be at the same price range, right? So whatever you could keep your product at about the same price range, and you could really increase the speed at which it ran, the frequency. So everything kind of rose up generation to generation. But it's not that same equation anymore. Transistors are actually becoming more expensive. We're getting down to where the very transistor that makes up the base, the foundation of a microprocessor or a graphics processor is only becoming several molecules of thickness of what's called the gate, the switch of the transistor. And so you really, as you start getting these molecular limits, it becomes more expensive. Innovation will keep semiconductor technology continuing to go forward. So we'll still get more transistors we'll pack in every generation, but you don't get the same frequency, the same speed increase, and the costs are going up. So it doesn't matter. The customers demand, as you said, that you get more and more performance every generation. So for those of us in the industry, that just means more innovation. We're innovating with how we design more features to give you more performance. On top of that, we're innovating around power management. We just had a huge initiative at AMD to increase our energy efficiency 25 times from 2014 to 2020, and we achieved that goal. I'm very proud of what the team did. So whether it be design for performance, design for energy efficiency, you absolutely can't miss a generation. You cannot stand still, and we're incredibly focused on that at AMD.
Well, I love the way you talk. So much passion.
Yeah, actually, in our business, you have to have a passion. It's very hard what we do, but you'll find as you talk to those of us in chip design, it is all about passion.
And then that desire and drive to keep moving forward. What you were talking about, discussing how they get smaller and smaller and smaller, and there's got to be some sort of limit. I think you call it like the gate or the switch. There's some sort of like physics limit. What happens next? Are there going to be like new methods of creating these processors?
There are indeed. Because I've been around a while, I've already hit about 2 or 3 times where someone declared the end of semiconductor advances because we hit a hard wall, and it just engineers, it's their very makeup, their psychological makeup. Anytime there's a wall put in front of them, it's like a challenge. It's figure out how you climb over the wall, you go around the wall, you find a way to blast right through the wall. But that's what engineers do, and that's what's happening on the semiconductor front. So you're right, we are just getting down to a few molecules thick, but now there's innovations on different types of materials. That you can actually build up that semiconductor. It's moving 3-dimensional. It's even the very structures that are being used are changing. So there just is not a lack of innovation, and so we see breakthroughs on the horizon.
That is exciting. Yeah, my mind works like that too. I see the wall. I'm like, how do I go over it, under it, through it? And then when I interact like with my wife, I remember that sometimes they just want to talk about the wall. I'm like, oh, we're not trying to problem solve the wall. We're just talking about how the wall exists. That's what we need to do right now. So
No.
any technologies that you're specifically excited about? Like if you had to guess what would come next, or what's the most realistic moonshot type deal, what technology do you think that would be?
Well, before the moonshot, you're seeing a change of foot right now, and that is something that we pioneered at AMD really 10 years ago, and that is starting to put CPUs and GPUs together. So, the GPU, think about, if you're a gamer, you buy your CPU, and then you buy your GPU, and you pick and you choose. What we've started doing 10 years ago is integrating very tightly the CPU and GPU, and you've seen that in, for instance, the PCs that come out now. You can put in an additional graphics chip, but the performance has gotten so high with the integrated GPU that we have with our CPU that you don't have to. You can get AAA game titles that play beautifully just in a single chip, because it's integrated so well. The functions that want to be in a CPU or a GPU, and how you manage and get the best performance wherever the software application or game that you're running wants to be, and that's growing. And so game consoles, of course, deploy that same approach. And now we're moving that same type of what we call heterogeneous computing. It's different. It's not just one type of engine. It's a central processor, a CPU, a graphics processor, GPU. It's other dedicated accelerators and coming together on heterogeneous computing. So you're seeing that in those supercomputers that I just described to you. Now, those are built with a CPU and GPU that are designed to work very, very closely together. When you're a programmer, you don't have to think, am I programming for the CPU or GPU, and manage where I'm storing the data. It's what's called coherent, meaning it's all sharing the same address where you store the data. So this programmer speak, it's making it easier for them to code, leveraging this new type of approach of putting engines together. So that's not even far future. That's what we're doing now, and it's very, very exciting. And that's going to take us to the next decade of enhancements of these type of heterogeneous computing approaches. And then beyond that, it's going to be more and more what I call accelerators. So what's an accelerator? It works with that general easy-to-use programming device, but things that need incredible computation, can you send it off to that device? Of course, we're using GPUs and programmable gate arrays and specialized application-specific ICs for that today, but you'll eventually see quantum computing, where you operate at extremely low temperatures. You have just breakthrough kind of computing that can be an accelerator. So you could be doing your general tasks and the kind of computing we're developing today, and then send off the most difficult problems to quantum computing, where it can calculate a result and send it back. So again, Joel, there's just so much innovation coming.
And I'm such a geek. We're so excited. To be honest with you, the entire company over here, we've got about 10, 15 employees, has just been buzzing on our Slack for your arrival. Jake, our producer, is a huge fan. He builds his own computers, and he always uses the AMD stuff. And I told him, I said, look, I know you have 100 technical questions, details about product releases and stuff. Let's just put that on the side and just have a nice conversation with Mark. And then you can send him an email after if you have some really highly detailed questions. But I was kind of curious, are you guys building any quantum computing, or how do you look at quantum computing? Well,
right now we're building out what I call that heterogeneous computing infrastructure. So the way that we're working with quantum is we want to be what I call the best hub for a quantum accelerator. So we're designing our computing such that it's very easy to attach. We create many connection lanes, so you could connect up to an accelerator like quantum compute. Our whole software approach, Joel, is open source. We want, whether it be academia, whether it's industry, we want to be able to partner with everyone out there to develop, a software approach that everyone can innovate on, and we want that to extend, out all the way through as quantum becomes more prevalent in its deployment. So that's how we see ourselves. We'd like to be a glue for collaboration in the industry and have a platform that makes it very, very easy to collaborate.
That sounds really smart. It reminds me of like Elon Musk open sourcing his patents on the batteries so that everyone kind of move them forward or buy them. It seems like your approach to open source will allow you to remain competitive. And I mean, also since it's open source, you could attract talent that way, right? Through seeing who contributes and who's doing things. I really like that model.
It creates a whole innovation community. It's a proven model. It just works.
Yeah, life is better together, right?
Yeah, exactly.
So when you got to do, I happen to have an Xbox. I play maybe 30 minutes a week of video games just to go blow off some steam sometimes. And I was curious, when you got to do those partnerships, did you personally get to be involved with like meeting with the Xbox teams, or was that just someone else on the team?
No, we, you know, as we got the whole dialogue going, I certainly was involved with the leadership with both Microsoft and with Sony. And it was, again, I'll go back to the theme we were just on. It was about, you know, co-innovation and collaboration. You know, what did we need? You know, what did we need to do? What were the goals? Then we created our own group, a separate group that worked with Sony, a separate group that worked with Microsoft, and they of course did the engineering. I don't claim anything to do with the amazing engineering that was done across that collaboration, because that's done at a very, very detailed level. But the results are phenomenal. When you look at, you know, and I'll talk about the next generation of graphics in just a moment, but you look at that generation that, you know, was out there with Xbox, you know, X and Series X and the PlayStation 4, and think about gaming when the physics is being calculated real time. It used to be that when you played games, and anyone had hair that, you know, the character in your game was going, they typically used to have skull caps. Well, in that generation of gaming, the math, the physics is running. It's calculating what does the hair look like when it's blowing in the wind. And in that generation of games, you see it. Now with this next generation coming out, it's even beyond that. It'll include, this is with our Radeon DNA 2. It's our latest in graphics processing architecture. And it includes also, in addition, even more rapid processing of all that math to give you beautiful imaging. It also has ray tracing and right in the chip. So as the light is bouncing around, you know, from the sun and what is it reflecting off of water or a car in your car chase, it's mimicking the actual light rays and how they behave in real life. It's calculating it and it's rendering it right back to you. And so it's incredibly lifelike.
I saw a demo of Unreal Engine, like their next version coming out on like a YouTube video. And they were talking about all those points and polygons. And I'm not an engineer over there. My experience is more in like the B2B business logic space, but I still can geek out over there. And I was blown away by all the points. They were talking about like billions of points, and they were doing the dynamic sun and the hair and the wind and showing all of the environmental changes in real time. And that stuff's only possible with, you know, amazing chips, right?
Absolutely. Them. No, it's tremendous processing power underneath.
Can you give me this might be a tough one. I don't know, but can you give me like explain to me as if I'm a small child, like exactly what a processor is or what it does?
Sure. So what you're doing, all of us think about processing from the standpoint of the application we run. You're on a smartphone, you're just running an app. You're on your PC and you're doing a video conference like we're doing today. But you know, you're playing a game, you're creating a document. All of that is a program that you're running. So someone created that application. They wrote the code. They created that application. They probably did it at a very high level programming language like C or C++, or maybe they used you know, Python. That's becoming, you know, very popular. A number of new languages coming up, but they wrote at the high level because that's your most productive way to create an application. What we do at AMD and our processors is we make it easy to translate from that program that you wrote into the best possible performance and the best possible experience. So we think about how do you take that program, break it down into low-level instructions we run on our processor. That's called a compiler. So it takes the program, it's compiled, it runs on our processor, and then we do the lifting from there. So we take those instructions, we optimize, we run it as fast as possible. Does it run on a CPU? Does it run on a GPU? Make sure it's optimized for both. Get the answer back as quickly as possible. It has to be 100% correct. We spend on an amazing amount of money and focus and engineering innovation to make sure that every chip we goes out is exactly right and performs those calculations as expected, and that it delivers the best experience. That experience would be, we have the whole set of coding to send it to your display. We have the things we've done like FreeSync, such that if you're watching a game, you don't get any tearing of the image, any stuttering going on. If it's running on the computer that's just a pure calculation, that's Excel, that typically the best experience there is to get you that result with the highest possible performance. So we think about our role at AMD and other processor vendors. We're that engine under the covers, so that when you're running that application, you just love it, and you're really pleased. If you bought a new product from a previous generation, that it's faster. If it has graphics, it's just much more lifelike going forward. And so that's our role in the food chain, is to provide better and better computing and give people a better experience.
And then you guys have a new architecture coming out this month, right?
We do. We've got 2 products we're launching. One later this week, new CPU architecture. We have a family of high-performance CPUs called Zen. That part of the whole turnaround of AMD is re-architecting our development process, re-architecting our CPUs to be the highest of performance. And this is the 3rd generation of Zen coming out, and it's the designers, I couldn't be more proud of them. They just made changes around almost every aspect of the computing to make it, just per my previous comment, run better, run faster, give a better experience, be a better gaming processor. So we've got more details on that coming out this week, and that architecture will be coming out in leadership Ryzen desktop processors this fall. And then on the graphics side, it is our 2nd generation of Radeon DNA. That's the graphics architecture that will be coming out in the new PlayStation, the new Microsoft Xbox Series X this fall, and it'll be coming out in our next Radeon graphics product that we'll be announcing on October 28th. So yeah, two big announcements coming up this month.
Who picks the names for these products like Radeon?
That's a great point. I love watching that name process. It's really I personally just love the process. I'm never the one that's trying to pick the name. I like it best when the team picks it. So you think about Zen, our whole family of processors. That was our code name. Our internal code name is before not a single marketing person was involved. And the team named it Zen. Our lead architect actually named it Zen, and it stuck. Everyone loved it. And so by the time the marketing team came along, they said, "We're going with Zen." And then we played off of that to create Ryzen, which is our brand name there. And likewise, when you look at Epic for servers, when you look at Radeon and our products there, it's generally a mix of typically the engineers being engaged. Look at our Ryzen Threadripper. They call it Threadripper because it's just such a beast. That was, just 100% named by the engineering team. So it's always very fun watching the naming process play out.
I love the strong engineering culture over there. Sounds like you guys have a great group of people together. We're
an engineering company at heart, and everyone just again, they love what they do, and I think it's actually our one of our secrets at AMD. It is about our culture. It is that People really love the innovation process here and work very, very well together.
Yeah, it's like a competitive advantage, right?
Definitely.
So in this market, I have another guest question, and this is from a financial person. I don't know why I said it like that. It's like, oh, it's from an investor person. Now I'm not going to put their name. Sorry, Nigel. Yeah, so Nigel from T. Rowe Price, he says that the industry looks like a classic race to zero and a commoditized space, but at the same time, there are a lot of niche uses where the margins for the processors and innovation will remain high. Like, how do you think about that?
Well, there's always a race to commoditization. So you just look at any industry, there's a desire for commoditization because it makes whatever that product is more available to people. So we are about trying to get computing to the masses. We want to get more efficiency of our computing. But put your financial cap on, and of course you need to return to shareholders. You need to have a sound financial basis. We spend hundreds and hundreds of millions of dollars each year in terms of our R&D expense. And so what we do to make sure that we bring the financial return to our shareholders is make sure that as we're providing value, that it is differentiated, that rather than pure commoditization, that although we've done everything we can to do and make it affordable, we need our product better. We want to have the highest performance, the best ease of use, the best ability to integrate our technology in tailored solutions like those game consoles I described. Those are all things that allow us to leverage a base commodity like an x86 processor, but the way we implement it, have it command value. The same thing with our graphics processing. It's got to bring a value that people are willing to pay for. So that's how you differentiate yourself when you compete, and what certainly is a race to commoditization.
I'm glad I asked that question. I debated in the prep call for this, like whether I was going to ask that or not. But then I was like, you know what? This guy, so experienced and so professional. I bet you he's just going to knock it out of the park. You did. Thank you.
I love talking about this whole area. So you're going to be hard pressed, Joel, to find a question that I'm going to not enjoy chatting with you about.
I don't want to. I just want to have a great conversation. So what is like the biggest problem / opportunity that exists today in the processor space?
Well, I think one of the big challenges goes back to what I said earlier. The fact that it's getting harder to just rely on a process technology and have some design innovation. The degree of design innovation to keep processing going forward at the historical rate that I described, doubling about every 2 years, 2+ years, it does mean that you're having to specialize more on what is that application that's being run. So there's more specialization if it is gaming. There's more specialization if it's supercomputing and artificial intelligence. There's more specialization if it's not necessarily in a data center, but what's called the edge of the data center, right? At the base of a cell tower with 5G emerging and about to create this massive pipeline of data flow across the world, and onwards into embedded devices. You already see that with all these Internet of Things. That's an area we've chose not to play. Is, let's say, a processor on a thermostat that's on the wall or embedded in your refrigerator. That we believe is in fact already highly commoditized. But it is the challenge is that what you're seeing is a development where more and more specialized computing is needed.
I like that, right? And then that way, because it's all about how you mentioned earlier, market and value and being useful to others is is the way you grow a business, right?
Yeah.
And so your expertise and being able to do things like dedicated team to help make a processor specialized for like a healthcare specific use, right? That's going to be very, very useful.
Yeah, we did that. The other thing I probably didn't mention that I should have is we also have designed in a modularity with what we do. So as you need to tailor, as you need to specialize, we've changed our engineering approach to be highly modular. So it allows us to customize for a given compute application without having to start at ground zero and construct it, transistor by transistor as a new and different product. We can leverage work that we've done.
I love it. Can we talk a little bit about like professional development?
You bet.
Is that okay? Yeah. So you were at IBM for like 26 years. Is that correct?
That's right.
All right. So I was trying to come up with like the most valuable thing to ask because 26 years is a long time. And so I want to know what is the one takeaway you have from that entire experience?
Well, IBM at that time was, I think, one of the storied companies in terms of driving a very rigorous employee development and training. And so, I'm very appreciative of the kind of training I had. I early on had, a graduate degree I did while I was working. They're very supportive to get a graduate degree. I chose to go into technology management and was able to get, not an MBA, but MBA training, many courses taught by MBA professors, management training along the way. So as a IDM, as an integrated developer from chips all the way to end products, I think, IBM for me was just a great way. I learned a lot. I think I feel proud I was able to contribute a lot back. The products did very, very well during the tenure I was there. So it's, IBM is clearly a storied company when you look in the annals of computer development.
Yeah, when you were there, so many things were happening. Two of them that I remember pretty well were like the browser wars, and then the processors. I remember driving over this bridge, and there's this billboard, and it felt like every time we drove over that bridge, it would be like a new version of the processor being up on the screen. I was like, oh, what number is it today? And so it was very competitive. Do you have any good memories or stories from either the browser wars or the competition in the processor space from being at IBM?
Well, I'll back up before the browser wars. Let's just talk about the advent of the PC, because that really shook up the industry. And IBM had been known for proprietary, approaches, and looking at the PC space to really open it up, actually published the specifications of how to build a PC, and it spawned an entire industry. Many of us working in the development of computers today would not have such a robust field to be able to work in had that PC not been opened up to create a standard. And then again, the idea was let performance, let differentiation went out. Very similar to our thinking that I described to you at AMD. And you look at there's always been I'll say wars. There was VHS versus Betamax, which many of the listeners here won't even know what I'm talking about. But the old videotape standards. There was operating system standards. I mean, Windows and Mac OS, Linux are so prevalent today. But think about the whole myriad of other operating systems that are still legacy operating systems or very active operating systems today, but have had various battles along the way. And browsers just another example of that. I mean, such development of with the very start with Mozilla and early browsers, and now it's a very robust competition. So I think it's just symptomatic of the industry is the end users, the customers, they benefit. So we're big believers of that at AMD. I just think it's just proven to be the path to the most impactful innovation at the end of the day.
And that's something that exists in the industry right now between you and the competing chip manufacturers. They all use a similar standard.
In many areas, yes, and in many areas, there's a lot of hard work required for us to be able to land on those standards. You look at how you just look at a PC. You plug a connector in, you use a USB. That's a standard, and that's very actively worked on. Or the other big interconnect standard is PCIe, and so those type of interconnect standards are evolving, and I think the industry is working very, very well. The next big challenge I see is in software, particularly around machine learning. And landing on standards there that can create an open ecosystem. This is something we're very committed to. We've opened up our software stack around machine learning. Others are proprietary that are out there. But you're starting to see more collaboration on this front. And we're certainly very, very active in promoting that. And then another area, Joel, that I would say is security. Everybody has to trust that whatever computer you're working on, that your data is safeguarded. And so I'm starting to see a lot more collaboration in the industry on security and making sure that all of us can have full trust in the computing. We just rolled out a set of features with our servers that can allow encryption, where the user controls, they have the keys, they control that unencrypting the data. In fact, Google Cloud just rolled out just a few weeks ago what they call confidential computing that uses those keys and protects that. VMware just announced a support for our encryption capability last week, and others are coming and partnering with us as well. So yeah, there's a number of areas for collaboration that we can build on success stories we have and do even more.
Are there big companies like this in other parts of the world that we don't know the brand of, or is this just what is available in the world? Like when we talk about like the AMDs or like the Intels and like the different, is that like a global thing? Or if I went over to like a country like that maybe doesn't have English as a primary language, they would have an entirely different, similarly sized processor manufacturer?
Processor development is international. So we are a multinational company. Our competitors are multinational. We have engineers across the world, sales and distribution across the world. So, computing, commodity computing like we do, x86, GPU, the world needs computing, and that's who we service.
Nice. So back to your time at IBM, when you were there 26 years, then you move over, you could have done anything you wanted in the world. Like anybody would have hired you. They'd be like, come lead us, Mark, right? So why did you choose AMD, and what was the story like about like how you met them and how that all went down?
Well, I had known AMD for years because I had at IBM I had used their chip technology and used it very successfully, and I always really admired the innovation of the engineers there. Just fantastic, and the culture. Culture was one of engineering collaboration, and so I got a call from a gentleman who had been the head of R&D during my time at IBM, and he was on the board at AMD, and he said, "Mark, this is an opportunity of a lifetime to have an impact in the industry." And I said, "I don't know. I'm busy. I've got these other things going on." He said, "This was Nick D'Onofrio." And Nick said, "Mark, if you don't take this role, CTO, and run the technology and engineering, I might need to come out of retirement because it's that kind of opportunity." And I have such immense respect for Nick. I said, "Nick, you don't have to come out of retirement. I'm going to take this role," and it has been phenomenal. I've probably never worked harder and never had more fun in my life.
Oh, that's awesome. And I think that's useful when you share stories like that, because other people are, at companies for a long time and they're curious about like what the next move is for them. And I find that from the feedback I get from the audience, that just stories of how things go down tend to be some of the best way to help, because that's what we're here to do, like help the next generation of leaders not make the same mistakes, right? Do better than we did.
Absolutely.
Yeah.
It's a responsibility all of us have to mentor others and pass it on.
What are some of the lessons that you've learned multiple times over?
Well, probably the biggest lesson is just communication and transparency. I mean, we stress it amongst our teams. I stress it. My leaders and my team stress it. When you don't have just open and candid communications, you just aren't working on the right things. People, anyone that they think that they can sweep a problem under the mat and it goes away, it's just wrong. Problem festers. I mean, so you really, I think one of the things that I always stress is, and I touched on a little bit earlier, create the right culture, create a culture for openness. That in turn creates a culture for better problem solving. That in turn creates a culture for better innovation and risk taking and risk management. Make sure you take the right amount of risk, not too much risk. It just all builds on itself, but it starts with that foundation of phenomenal communication and collaboration.
I like that. Communication is something that you work at it. I mean, it's a hard muscle to keep really strong. Like, it seems like you're always working at it, right?
Well, Joel, you're pretty darn good at it. Given when I look at what you do. Congrats.
Thank you so much for the kind words. I really appreciate it. We have actually about 10 minutes left here. And I was just curious, one of the things that people have been asking us, and we have not done this yet, is they've been asking us to put together like small groups, right, of people so they can talk, because they said like 50 is too many when they go to a conference or whatever. They kind of want a group of like, 8 or so, maybe 7, 8 people to get together and like talk about whatever the topic of the group is, whether it's, hyper growth or just being a CTO. And so now I'm kind of soliciting feedback from people, because I've never been a part of one of those groups. Like, I speak a lot, so I'll go speak at groups and things like that, but I've never participated in one of these small groups or mastermind type things. Have you ever done so? And do you have any experience there?
Yeah, let me give you a couple comments. First of all, I do think that's extremely important. So first, I'll say, what do we do internally at AMD, particularly with COVID-19 and many working from home, and most all working from home. We have quite a bit of our locations are still in a work from home mode, and what we found is it caused us to even expand what we used to do before. We used to have small meetings. Where a cohort, where a small group of people could get together, talk about what's going on. Hey, what challenge are you facing? Well, how did you solve it? And you hear how another person may have an idea about solving that problem. So just in any company in the industry, I'm sure most are doing what we are. They're really supporting that and getting virtual, like the mobile meeting today, getting many small cohorts where it's easy to get that kind of dialogue going on. But we used to all be able to network and go to an industry event and have those kind of side discussions or in a hallway in an industry get together. And so more than ever, I do think there's a need. I have participated in several where we've, so obviously pre-COVID, but now post-COVID, it's been a format like here where we've had, a number of CTOs. We've done this, CTOs, CIOs, technology folks, and just create a forum for discussion. I personally found it very beneficial. So I do recommend it.
So because we're all about what's useful to people, because that's our mission. So when you said CTOs together, is that like within AMD, like different business unit CTOs, or have you been a part of groups that are like another type of group?
Yeah, no, I've done so both. So I did give you that example internally, but what I was referring to in the last comment was externally. So I have participated in some CTO roundtables, some CIO roundtables, and again, it was good to hear how other people were dealing with challenges with the COVID-19 environment and just other industry challenges.
Now, is there anything, we've got about 6 minutes left, is there anything that we didn't get to that you want to get out there into the world?
Well, I think, the thing I would just challenge all the listeners to do is, just think about the dialogue that's occurring. I mean, it's a turbulent time in our society right now. And, we sometimes, your audience is a technology audience. And so we can say, well, that's not us. We're not, uh, we're not having to get in the middle of that. But I think all of us, it's a time where our technology is more important than ever. We are enabling people to take on challenges like COVID-19. We're enabling people, whether it be in their work, at their play, to be more productive and more effective. And I would, that I did spend some time with you today, Joel, just talking about, I think, aspects that often go untouched, and that is the very culture that each of us develop in our workspace. And what are each of us doing to create a workplace that's that's fair, that's diverse, and just values everyone's opinions. I think those are really key elements of a successful and thriving technology and engineering culture. And so that would be, if I was to leave one challenge to your listeners, that would be it.
Oh, awesome. So well spoken. What a professional. I was so excited to have you on, and I'm even more excited to have you on again next year. We can catch up. So we did it, my friend. We made a podcast. How do you feel?
I love it, Joe. It was just a fun conversation with you.
So hopefully some of this computing, these advancements will build these machines that are smarter and can process more variables than us, and we'll make this world a better place, my friend.
No doubt. Joe, it was really a pleasure. Great to meet you, and thanks for having me on your podcast.
Thank you so much for coming on, Mark. Talk soon.
Thanks. Take care. Bye.